Good evening, dear students. This is Mr. Mundhe, Assistant Professor in Chemistry. In last lecture, we had seen the synthetic drugs and dyes, in which we have synthesized various drugs and dyes and seen their uses. The drugs such as sulfonamide, benzocaine, paracetamol, aspirin, tolbutamide were synthesized and seen their uses, and also we had seen the synthesis of dyes such as indigo, methyl orange, orange second, alizarin, and other dyes, Congo red, all those. Now we have successfully completed the topic, that is your unit 3rd. Now after completion of the unit 3rd, we will continue the next unit, that is 5th unit. We have dropped the 4th unit because for your internal examinations, to carry out internal examinations, we have to complete one inorganic unit and one organic unit. So that I have chosen to complete the to teach you the next unit. So the unit that I am going to teach you is 5th unit, and the name of the topic is coordination chemistry first. Coordination chemistry first. Okay, now see, this is the part of your inorganic chemistry. And in this part, today we will see what is meant by coordination chemistry and what are the applications of coordination chemistry in day-to-day, in our day-to-day life. Okay, now see, inorganic chemistry is the branch of chemistry that deals with the study of salts and minerals. So coordination chemistry is the branch of inorganic chemistry, and in this we study the coordination compounds. Coordination compounds. Then we will see what is meant by coordination compounds and the terms involved in it, and after that we will see one by one further topics. Now, coordination chemistry. What is meant by coordination chemistry? The branch of chemistry that deals with the study of preparation and properties of coordination compounds is known as coordination chemistry. This is the general definition of coordination chemistry. This is the general definition of coordination chemistry. Okay, now see, in inorganic chemistry, the salt exists in two forms. In inorganic chemistry, the salt exists in two forms. One is addition or molecular salt, or we say it as addition or molecular compound, and another is known as double salt. Sorry, simple salt. Another is known as simple salt. One is addition or molecular salt or compound, and another is simple salt. Simple salt means your table salt, that is NaCl, sodium chloride, potassium iodide, potassium sulfate, sodium carbonate. All these are the simple salts. But what is addition or molecular compound or salt? When two or more simple salts are combined in a stoichiometric proportion, then newly formed compound is known as addition or molecular compound or addition or molecular salt. It means when we combine two salts, simple salts, such as I will say it as KCl plus K2SO4 or Na2SO4. When I combined these two salts, at that time a new type of salt is found, and that is known as addition salt or molecular compound. So this is the molecular compound. So now this molecular compound has been classified into two classes. The first one is double salt and the another is coordination compounds. The first one is double salt and another is coordination compounds. Okay, it means your salts have been classified into two categories, simple salt and addition salt. Then the addition salts have been classified into two categories. One is double salt and another is coordination salt. Now see, the salts, simple salts are formed by the action of acids on the base. Action of acids on the base or action of base on the acids, you can say anything. So that acid, when an acid reacts with a base, at that time a new salt is formed. For example, when HCl reacts with NaOH, at that time it gives to NaCl plus H2O. NaCl is the salt. So in this manner you can prepare any simple salts, and when you combine two or more simple salts in stoichiometric proportions, at that time a new compound is formed, and that compound is known as molecular compound or addition compound. So the addition compounds are of two types. Now the first type is double salt and the second type is coordination compounds. The double salt, first is the double salt. What is meant by double salt? The addition compounds that dissociate into their constituent ions when dissolved in water are known as double salts. The compounds, the addition compounds, when dissolved in water, they get dissociated into their constituent ions, and that addition compound is known as double salt. For example, Mohr salt is the double salt. This Mohr salt is when dissolved in water, at that time it dissociates into its constituent ions. Its sulfate ion gets separated, potassium ion gets separated. Each and every ion of that particular addition salt gets separated from each other, and they show the properties of the individual ions or the properties of their constituent ions, so that these are double salts. These are double salts. What is the definition? The compounds that dissociate into their constituent ions when dissolved in water are known as double salts. Okay, then the double salts show the properties of their constituent ions in solution, and the example is Mohr salt. Now the next is coordination compounds. The next is coordination compounds. What are coordination compounds? The addition compounds that do not dissociate into their constituent ions when dissolved in water are known as coordination compounds. It means double salts were dissociating into their constituent ions in water, but in case of coordination compounds, the coordination compounds do not dissociate into constituent ions in water. It means the coordination compounds do not split up into its constituent ions, so that the coordination compound shows the properties of their own as a complex. They show the properties as a complex, but the double salts show properties as individual ions. Okay, so it should be mentioned that the coordination compound complexes show the properties of their own complex and not that of ions. And the example is hexaamine trichlorocobalt third. Hexaamine trichlorocobalt third. This is the example which is to be shown in this on the screen. Okay, then another, I will again repeat the definition of coordination compounds. The addition compounds that do not dissociate into their constituent ions when dissolved in water are known as coordination compounds, and the example is hexaamine trichlorocobalt third. Okay, then the next is there are some terms that are used in coordination chemistry, and we must be familiar with those terms, so that we must study about them, and these terms are here for your knowledge, and this is your terminology. So the first term is complex ion. What is meant by a complex ion? Okay, now see, the complex ion is nothing but it is the combination of central metal ion and ligands. It is the combination of central metal ion and the ligand surrounding it, and nothing much more than that. And this complex ion is, or when the central metal ion and the ligands are closed in a square bracket, at that time we say it as complex ion, or simply a complex. If it carries a negative charge, at that negative or positive charge, at that time it is a ion, but if it do not have any charge, at that time it is a simple complex. Okay, so you can say it as coordination complex coordination ion or complex ion. So the example is FeCN6 3 minus hexacyanoferrate third ion is the example of this complex ion. Okay, then the next is central metal ion. Then the next is, second term is central metal ion. See, the central metal ion is the metal ion which is attached to the ligand in a coordination complex. This central metal ion is nothing but the metal ion that is present at the center of the ligands is known as central metal ion. See, in case of the example in K3 FeCN6, that is, we say it as potassium hexacyanoferrate third, iron is the central metal ion. See here, there are two metal ions, but potassium is out of the square bracket and this iron is in the square bracket. So central metal ion means internal ion. Okay, so this is your Fe plus 3 is your central metal ion. So the next term is coordination number. Coordination number is nothing but the number of ligands that are directly bonded to the central metal ion is known as coordination number. It means when a central metal ion is directly bound to different ligands, and the number of ligands is known as coordination number. So see, in the case of the above example, that is potassium hexacyanoferrate example, the potassium is bonded to 6 Cn minus ions, so that the coordination number of iron is 6. The coordination number of iron is 6. Okay, then the next is coordination sphere. The central metal and the ligand bonded to central metal ion are enclosed in a square bracket, and these are collectively called coordination sphere. This is similar to that of complex ion. Both the terms are same, because there we have seen ionic in the ionic form. Here we are looking without any ion or non-ionic form. Coordination sphere means the terms or the what we see it as the molecules or the atoms or ions are enclosed in a square bracket, that is called coordination sphere. And this coordination sphere includes central metal ion and the ligands directly bonded to it. So that coordination sphere means nothing but it is similar to that of complex ion. It is similar to that of complex ion. So the next is ligand. This term is very important, because it could be repeated again and again in next lectures. Central metal ion and ligand. Now what is meant by ligand? Ligand is an atom or group of atoms that donate a pair of electrons to the central metal ion is known as ligand. An atom or group of atoms that donate a pair of electrons to the central metal ion is known as ligand. Okay, any group or any atom that has the ability to donate the lone pair of electrons to the central metal ion is called ligand. This is the simple definition of ligand. Now see, the examples of ligand are NH3, Cl, Cn-, oxalate ion, sulfate ion, anything that is directly bonded to the central metal ion or that has donated the electrons to the central metal ion. A ligand may be neutral, anionic or cationic. The examples of the ligands have been given in a list below this terminology, and you can see here the coordination space, charge number or charge number, then coordination number, central metal ion and ligands, the terms, and then here is the list of ligands and their names. Here you can see. Okay, now come to the continuing point or ongoing point. The next term is the types of ligands. The ligands have been classified into 4 to 5 types, and based on their ligacity or denticity, I will say it as denticity. Also, the ligands have been classified into different classes based on their nature, acidic, basic or neutral, or we say it as anionic, cationic or neutral ligands. Okay, so for our syllabus or to the point of view examination, we have taken based on the denticity, the classification based on the denticity. So in tomorrow lecture we will see the classification of ligands or the types of ligands. Up to that, thank you, best luck.